All right. Good evening, everybody. So this is not the right date. This is what we talked about last time. We did chapter four review. Today, is day nine, which is June 16th. Today we're going over chapter five review and another cumulative review worksheet. So this one will cover chapters one through five. Also, you'll want to have done before Wednesday the 6.1 lecture notes. So that's the start of chapter six. So chapter six is part of the midterm. And so on Wednesday, I'm not going to be here, but Cindy is going to cover the chapter six review with you guys. Okay. Um, and then after that, on Monday the 23rd, we're going to cover the sample midterm. Now, the sample midterm is still going to need to be turned in. So it's part of your grade, it's part of your worksheets, but it's pretty big. Okay. It is bigger than the midterm. Okay. So we're going to cover as much as we can. So if you get done with any with chapter six review early on Wednesday with Cindy, you might want to start the sample midterm. Okay, just a suggestion. Um, it is going to be so the sample midterm is going to be due on the June 25th, on Wednesday the 25th. Okay. So like I said, it's big, but that's good because it's going to help you study for the midterm. Now, the midterm itself is 9 pages. Okay. So that's about two worksheets. Okay. So it's two and a quarter worksheets. Okay. So today we're covering two worksheets. We're covering chapter five review and cumulative review number three. Okay. So it's a little bit more than that. Okay, so you most students are going to be able to finish it in 2 hours. Um, we're going to finish these two worksheets today here in hopefully an hour and a half. Might go a little long today. But yeah, so if you need more time, when you do the midterm with me, um, I'll be here for 3 hours on the 25th. Now, if you need more than 3 hours, you're going to want to take it at the testing center. Okay. I sent out a document in Remind that has lots of information about the midterm. Okay. So make sure you take a look at that. Message Cindy and I if you have any questions. Okay. Okay,
So I
cool.
do want to
So,
mention that on,
yeah, go ahead,
I'm
Cindy.
sorry, I just want to mention on Wednesday when they attend my class to make sure that they're getting onto my Zoom link and not yours. Otherwise, I'm not going to be able to record because it's yours. So, yeah, you guys make sure I'll send out a reminder or an email to remind you on Wednesday. But if you're thinking about coming, and the same thing for the morning, you'll want to, if you're coming Wednesday morning, to get on Elaine's Zoom link.
Thank you for that reminder, Cindy. So, um, okay, great. So, all right. So today, we're going to look at chapter five review and cumulative review worksheet number three. So chapter five review is going to be on page 350 of your course pack. Um, while you're pulling out page 350, the cumulative review starts on page 381. Okay. But the chapter 5 review course in the course back page 350. Um, so we're going to finish this one tonight, just like other examples of the worksheets. We're going to work on them together. But I'll give you some hints for the ones that I think are super difficult. Um, so uh, this part's not super difficult. Putting your name on here, right? But chapter five is all about probability. So uh, probability is the number of wanted outcomes divided by the total number of outcomes. Okay, so uh, when we talk about outcomes, um, whenever you like roll a dice or draw a card or whatever, something's going to happen. You don't know what's going to happen. Okay. But you at least know here are the possibilities. All right. And that's the outcomes I'm talking about is what possibilities are there. So in the numerator of a probability is the number of wanted outcomes. So you have to count them up. Okay. and then the denominator will be the total. So, okay. So this first one, um, we're rolling a red die and a blue die. Okay. So roll a red die, it might come up 2, blue die 3. So is this probability disjoint or not disjoint? So sometimes you might hear it referred to instead of disjoint as mutually exclusive. Okay. All that means is uh, if two things are disjoint, then they cannot both happen at the same time. Okay. Not disjoint means they can. Okay. So in this case, if I roll a red die and it's a 2, and I roll a blue die and that's a 3, can both of those happen at the same time? Yes, they can. Okay. So this one's not disjoint. Okay. If I had rolled one red die, then I cannot have the red die comes up as a 2 and the red die comes up as a 3, right? You can't have the same die land on two different numbers. Okay. Okay. So we'll revisit disjoint and not disjoint as we go. Okay. All right. So most of this you guys can do, no big deal. Number 3 down here. Which of the following numbers cannot be a probability? Circle them. So there's a couple of answers. So here's your hint. Uh, there are 3 of them. Okay. So next page, page 351. Um, Probability experiment involves tossing a 3-sided die and recording the result, 1, 2, or 3. Okay, so we're rolling a D3. So then spinning a wheel, and there are 3 equal options there, red, yellow, or purple. Okay. So using the multiplication rule, how large is the sample space? So the sample space is how many total outcomes there are. And whenever we are, doing probability, that's our denominator. Okay. So we always need to know the total outcomes. Okay. So for here, we're taking two numbers and multiplying them together. Okay. So you do the first and the second. Okay. Um, Next, let's create a tree diagram to show all possible outcomes for this experiment. So the first thing we do is we roll a 3-sided die. So there's 3 possibilities there. Okay. So you're either going to get a 1, a 2, or a 3. Okay. And then if I rolled a 1, and I'm going to spin the wheel, I have 3 possible outcomes there. So I could get red, I could get yellow, I could get purple. Okay. So this would be 1R. Okay. And we'll list out all the different possible outcomes, and that's our sample space. Okay. So you should get the same number as what we got for part A. So if part A you get 20, then you need to have 20 outcomes down here listed in your sample space. They need to be the same. Okay. Explain what B2R means in English. This one right here is a typo. Part E to calculate part D, not part C. So typo there. Sorry about that. Um, Compute the probability of having a die roll of at least 2. At least 2 means 2 or more. Okay. You can read it either way. Um, okay, so that's fine on that page. Page 352. If you're worried I'm not giving you as many hints as I've given you on previous worksheets, it's partly because people usually don't have too much difficulty with chapter 5. Chapter 4 is pretty tricky, but chapter 5 Most people are able to handle it pretty easily. We'll still go over any questions if you get stuck on anything, okay? Um, so for this one, this table shows the numbers in thousands of earned degrees by level in two fields, so natural science and computer science. So for all of these, we're calculating a probability. Find the probability that someone earned a degree in natural science, earned a bachelor's degree or a master's degree, and so on. Okay. So for probability, we're calculating the number of wanted outcomes divided by the total. Now the total is this guy, 447.4. Okay. You're going to divide by that total. Okay. So this is the total number of possible outcomes. Now, um, this is the total of everything altogether. There are times in other classes where we might divide by some subset of the total, okay? That's called conditional probability. We're not there in chapter 5. For chapter 5, we're dividing by the total of all outcomes, okay? So uh, to do all of these, there's explanations on page 132 and 133, okay, on how to do these, okay, if you get stuck. Um, so one of the main things to pay attention to with probability is the difference between and or, okay? When we talk about we're talking about the overlap. So what's the probability that someone earned a doctoral degree and the degree was in natural science? So that's where those two classes of things overlap, okay? When we're doing or, we are combining them. What's the probability that someone earned a master's degree or the degree is in computer science? So either of those could be true, or maybe both. Okay. So to calculate this, you'll take the probability of a master's plus the probability of computer science. But if you do that, and these two things are not disjoint, that means that you can have a master's and have it be in computer science. If you just do these two, you're going to be double counting. So you have to subtract the overlap. So the probability that both happen. Okay. So and is always easier because you just are doing the overlap, which is just this guy. Okay. But if you're doing or, be careful because sometimes you need to subtract. Sometimes you don't. Okay. If it's disjoint. Okay. We'll talk more about that as we go. Another typo here on H. This is A through G. Yeah. Oh, and the next page, 353, there's another typo. This is number 6. Not that that matters. So, um, yeah, lots of typos today. The following probability distribution was created by Cascades Humane Society. So it's the number of dogs. So what's the probability that a certain household has this number of dogs? Explain what must be true in order for this to be a valid probability model. There's two requirements, page 118 and page 137, okay, in your course pack. Um, so 1 and 2. Um, you guys can do all of that. At least 2 dogs just means 2 or more, okay? Okay, this page, no problem. Okay, so that's all the hints I'm going to give you on chapter 5, okay? Um, but we have another worksheet to work on tonight, which is the cumulative review worksheet. And so instead of jumping into chapter 5 review worksheet and then when we're done, come back to this one, I'm just going to move on. I'm going to give you some hints on this one as well. And that way we can just work on both. Okay. All right, cool. So this is page 381 in your course pack, cumulative review worksheet number 3. So this covers chapters 1 through 5. Now, chapters 1 through 6 are the ones that'll be on the midterm. We'll talk about chapter 6 on Wednesday, and we'll also talk about chapter 6 when we look at the sample midterm on Monday. Okay. But for this one, so these data represent the percent of adults with obesity in a random sample of US states in 2020. Okay. So we are asked to calculate all of these things, X bar, Q2 mode, all of these different things. So we have data here. Now, on page 232, there are instructions on what you click on in StatCrunch if you want to do a mean or a standard deviation, depending on what you have. If you have a frequency distribution, you would have two columns. You'd have your midpoints, and then you'd also have the frequencies. I don't have that. I have the raw data. So that is method 1. Okay. Now, method 1 says you'll do that in StatCrunch. So if we go back to Canvas and we click on the cumulative review worksheet number 3, that'll let us get the data in StatCrunch without having to go through and enter it all ourselves. Okay. So if you click on that in Canvas, there's a link. You click on that link. It brings you to StatCrunch. Make sure you sign in, and it'll get you to the raw data here. Okay. If you didn't have that, I mean, you could just type all this in, right? So 35.3, 33.2, okay? I don't want you to have to do all that, okay? So, but if you ever needed to, because you don't have a link to the data, you can just enter it, okay? So as far as the different symbols, what all of these different symbols mean, uh, you can find those on page 5, page 6. Oh no, sorry, page 5, page 61. 5, 61, 68, and 83. Okay. Or your classmates will be able to help you as we're when we break up into groups. Oh, almost forgot to put my name on here. Okay. So for example, like N is my sample size, right? Capital N is my population size, right? Because populations is bigger than samples, okay? So it's capital. All right. Anyway, are the values above parameters or statistics? So that's on page 7 of your course pack, and that comes down to whether we're talking about a population or a sample. Okay. For fences, there's a formula for that. Find that on page 84. Okay. What's the shape of the distribution? We talked about that on page 87. Michigan had an obesity level of 35.2%. What is Michigan's Z-score? So Z-score is on page 232. Okay. There's a formula there for that. Okay. So remember, Z-score is calculating how many standard deviations you are away from the mean. Okay. So if we are more than 2 standard deviations away from the mean, we consider that unusual. Okay. So that's on page 80. All right. Next is page 382. All right. So this scatter plot shows the relationship between a U.S. state's annual alcohol consumption in thousands of gallons. Thousands of gallons of alcohol. That's our units. And annual drug overdose deaths for 2020. Okay. So here, this is my Y, this is my X. Okay. Reason I'm pointing that out is because they did the StatCrunch for us, which is great. But notice that the first thing is the dependent variable. Dependent variable is y, so they got it flipped. Okay, so be careful with that. Independent variable is my x values. Okay. Um, so if you aren't sure how to do this in StatCrunch for regression, that's all on page 233, right? Page 233 was all about chapter 4, doing linear regressions and so on. So luckily we didn't have if we had a set of data, we could have done this using the instructions on page 233. But um, all right, so part A, Michigan has a point on the graph at 1986, 860, 2,385. Explain what this meant for Michigan. Okay. So there's not really a script for this. It just means, you know, Michigan had 19,860 something. Okay, whatever the units are for that. And 2,385 something in 2020, the year 2020. Okay. So what are my units here? Okay. Uh, Strength of a linear relationship, you'll use R for that, not R squared. I mean, you can use R squared, okay? But you need R to tell you if it's positive or negative. What is the regression equation? So that's y hat equals something. So write out what that is. What is the slope? And give us context. Don't forget units. So slope, there was a script for that on page 233. Page 233 is all about chapter 4. Okay. What is the y-intercept? Y-intercept, remember, is always 0 comma something, 0 comma a number with parentheses. Okay. So don't forget the 0. Explain why this does not make sense. If it does not make sense, then our answer is going to follow something like this. It's impossible. It's impossible for something. Possible for what? Okay. So you're gonna fill that out. All right. Page 383. Following table shows the type of health insurance coverage and the race ethnicity for a random group of people in the US from the National Health Interview Survey in 2018. Okay. Um, so the column variable is what? So when I say the column variable, I don't mean, oh, if I look at this column, I have races. No, no, no. What I mean is, what does each column of data mean? Each column here, private, Medicaid, uninsured, each column with numbers in it is a type of insurance. Right? Each row, what does each row represent? Each row represents a race or ethnicity. Okay. Explain why researchers cannot conduct a designed experiment to obtain data on these variables. So, a design experiment requires that you have random assignment. Okay, so if I have a sample of people in the U.S., I can't randomly assign them a race, right? They already have a race. You're not gonna be able to change that, okay? Uh, I can't randomly assign them insurance, right? Like I can't be like, okay, you're gonna, you know, you're part of this study and you have Medicaid. I'm gonna give it to you, okay? You have to have, there's certain requirements, right? Or uninsured. Like I can't just force someone to be uninsured if they don't want to, right? Um, so the problem is that it's impossible to randomly assign race as well. I cannot randomly assign race as well as insurance. Okay. What was the sample? So the sample here was a random group of people in the US. All right. What's the sample size? What's the population? So the population is related to the sample. Okay. The reason why we took a sample here is because you can't look at every person in the US. That's the population, all people in the US, right? And that's too big to ask every single person how they're insured. Okay. Health coverage. Um, so health insurance coverage is an example of qualitative, quantitative discrete, or quantitative discontinuous. So qualitative is words, quantitative is numbers, discrete means whole numbers, continuous means we have decimals, okay? So we're not asking about these numbers, right? These numbers are frequencies, okay? Um, the health coverage that each person has, well, you either have private or Medicaid or uninsured. Okay. So those are words. So that means that this is qualitative. Okay. Is it unusual to be uninsured in the US? So use probability to explain. So remember that what did we consider was unusual? Okay. So we need to calculate the probability of uninsured and then check if that's unusual or not. Okay. Probabilities found in this table will be classical, empirical, or subjective. So the explanation for what those mean is on page 120. Classical means it's coming from logic or theory. Okay. Empirical means it's coming from data, like an experiment or a survey. Subjective means it's made up. Okay. It's just made up for nothing. Okay. That doesn't mean it's useless. Okay. It still has value. It's just that it might not be accurate. It's just completely made up. So an example of subjective would be like if I told my wife, you know, our baby didn't take a nap today, so or sorry, our baby took a really long nap today, so there's a 50-50 chance she's going to wake up in the middle of the night. Um, do I actually have data on that? Do I actually know it's going to be a 50% chance? No, I haven't been recording like her sleep habits. I just know like, okay, if she takes a really long nap during the day, then there's a good chance she might wake up. So in the middle of the night. So it's not useless though. It's still helpful information because, my wife knows like, okay, be prepared, right? But it's kind of made up. That's subjective. Okay. So continuing on with the same insurance information. Um, You're going to select a single random person in the US using the two-way table, find the probability that, okay, so notice that they're asking for 4 decimal places here. Okay, so sometimes we ask for 3. Here we're asking for 4. Um, so when you do a probability, it's wanted, you count up all the wanted divided by the total, right? And so the total here that we're going to be dividing by is the big total, okay? So this is our big total right here, okay? These are all totals. This is the total for white, total for black, total for private, but those totals are not the overall grand total of the sample. Okay. So you don't want to divide by these. That's what we would do if we were doing conditional probability. Okay, so uh you guys can do all of that. Uh be careful with whether it's and or, okay. Um Disjoint, we said that means it cannot overlap. Okay. Dis Not disjoint means it can. Yep, so keep in mind, so if it's an or, there's a formula if it's or, okay? You add the probabilities, and then if it's not disjoint, you have to subtract the probability of both, okay? If it is disjoint, means it cannot overlap. I did not spell overlap right. If it can't overlap, that means that this is just 0, and you're just subtracting 0, which means you can just ignore that and just add them. Okay. All right. All right. Well, that's all the hints I'm going to give you for tonight. So uh, we're gonna do what we've done before, where we stop the recording, break up into some uh, groups, and work on the worksheets. So for those of you watching the video, so hopefully those hints are helpful. But for everyone who's in the class, we'll make sure we go through all the questions and get all the answers right. So yeah, that's your reward for coming to class. So thanks for coming. And yeah, uh, don't forget on Wednesday, you're going to be joining Cindy's Zoom, not mine. Okay.